This is your key. Keep it where you want to.
Yeah.
Don't lose it, because otherwise you're not going to be able to operate the system. So if you want to operate the system in front of the panel, then you'd have the key into the local position. So that's giving you local control at this HMI. There's a third position called SCADA. You actually have the ability to operate the system through the SCADA system remotely. And you do that by putting it into the SCADA position. And then you can connect to the SCADA box and you can control it at the SCADA box, which I'll show that to you as well. On your left-hand side, you've got some other lighting indications. These are only lights, they're not buttons. But it's just giving you an indication of failure, warning or attention, or just straight operational. Your failure light is going to be red. Anytime you have a failure condition or a red light, it means the system is shutting itself down. It will go to bypass first when it shuts itself down, if bypass is available, okay? And then you've got a light that indicates whether you have an active warning, a lower level warning, and then a light indicating whether it's operational or not. And we'll go into more detail when we go over the operator's manual to explain what those lights will do. And then of course you've got a lamp test and a buzzer off. This is a button as well, where you can test your light indications. And then anytime you get a warning or alarm of any kind, you're also going to get a buzzer. A buzzer will sound. Now of course you're probably not going to hear it because of the noise in the space, but if this were in a separate electrical room, you would certainly hear a buzzer as well. And of course you've got your emergency stop button, which you can always press at any time for any kind of unsafe condition. Emergency stop, again, will send the unit to bypass and shut everything down. However, keep in mind that an e-stop action is not going to stop your shaft. Your shaft is still going to be spinning. So, you know, we have no way to break the shaft on an e-stop. So it's going to send the unit to bypass, it's going to shut everything down, it's going to remove excitation from the alternator, but the shaft is still going to spin. Just be aware of that. The diesel will also shut down if the diesel is running. Okay. Let's take a peek inside real quick. In our UCP cabinet, again, this is our PLC. It's the brains of the unit, the whole operation. This is our Dicon Mark II, what I mentioned in training. This is the heart of our system. So this is our monitor, controller, protective device. And you'll notice I mentioned it has some light indications on it. So it'll give you certain indications of health, power. It'll give you indications of utility, voltage and frequency, load voltage frequency. You'll notice here it has a synchronous to utility. So it can tell you when it's running synchronous with utility for closing Q1. It has other lights that don't apply to you. For dual output systems, it has short break as well, but that doesn't apply to you. But again, just some light indications that help our service guys to help, you know, troubleshoot certain parts of the system, or to give indications of, you know, health of the system. There's kind of little cheat lights. And then there's just various other little devices, MCBs, protective devices, power supplies, network switches, and so forth. This unit, this PLC, communicates with all the other panels through a IP network. So each panel and each device that is linked to the PLC has its own specific IP address. So that's how it communicates. There's Cat6 cables that run from panel to panel that basically establish the network so that this unit can communicate with the switchgear and the other panels. A little Blackstart battery. When the utility goes away completely, we're still able to start the unit if need be, because there's a little Blackstart battery that provides 24 volts temporarily to all the controls to allow us to start the unit if we need to for Blackstart. I'm sorry?
How long will that battery provide power?
I would say the battery itself is not meant to operate very long before you start the system. It actually has a timer in it where it will shut itself off after a while if it's active, but not if you're not starting the unit for a while. So I would say it probably, if held to it, it'd last for about 20 or 30 minutes.
Do we lose any programming if it goes dead?
Right.
Do we lose any programming if it goes dead?
No, no, all the programming is permanent. All the settings and the programming actually in the PLC. This is completely dark right now, so when we re-energize the mains and get power back to this unit, it'll come up. All the settings will be in it. Okay, right on the other side, this is our medium voltage switchgear. Okay, so this is the medium voltage panel that houses all of our breakers. In this section, we have that 45 kVA CPT so that we can put some utility sourced power for 480 volts into our preheat, for example, or Prelube. It also provides utility power into our UCP so that we can power up the UCP if need be from utility alone. And we've got the other sections which contain the breakers themselves. So we've got our input breaker right here on the bottom of section 2. We've got also PTs on top, for voltage sensing as well. This is the PT for main sensing on top here. Each breaker has a Schweitzer protective relay, 551s for the main breakers. The Q20 breaker actually has a 387 because it's part of the differential zone protection that was set up by Stanley. But we've got the Q1 breaker here. We've got the bypass breaker on section 3 bottom. And then we've got the output breaker Q2 section 4 bottom. And then on the very end is our Q20 breaker, which is feeding our generator transformer panel. Various meters as well on the gear itself. We've got mains voltage and frequency on these 2 meters. We've got the actual meter for the output bus right here, and then on the extreme end we've got a meter just for the generator output itself. All of these breakers and the PTs, you'll notice, have a racking interface that you can manually rack out the breakers in PT drawers. However, the system also came with automatic racking system for racking in and out the breakers.
Is there a password on that thing?
No.
Okay, so just turn it on and it just...
Yeah. The you see if the box is here. The remote racking system is you don't have to manually rack in and out the breakers. There are motors which will do that for you, and there's a box interface that you just plug in to these racking ports, and the box is powered directly from the port. And it basically, you can give a command to the box to rack in and out the breakers. We can't do it now because everything's shut down, but basically, once you plug this box into these ports, this comes alive, and it gives you push button indications that allow you to manually rack out the breakers or rack them in. So you can actually, with the cord, you can do it around the corner if you want. You don't have to stand in front of the breaker to rack it in and out. It's a very nice system. Of course, you can always manually do it as well if you're forced to, but it's quite a chore. It takes a lot of effort to rack in and out these breakers. There's some test switches for the CTs and PTs as well, and for the meters, if you ever need to run tests of the protective relays, for example. And every high-tech controlled breaker, Q1, Q2, and Q3, comes with what we call an HOA switch, auto trip and test. I'll go into how these are used when we go over the operating instructions. But keep these in your mind as far as what they look like, because we'll go over how those operate in upcoming sessions. Okay. So again, all this 4160. Right here by the UCP. On the other side again, this is our choke cabinet. This contains our URP, our reactor choke. This also came from Europe as well. And you can actually follow, if you look out on top of the gear, you can see the connections into the UCP, into the URP. Again, coming from the URP Q1 and also going to the Q2 breaker. But this is where our choke sits. Again, this is medium voltage as well, 4160. So this is the GTP, generator transformer panel, fed by the Q20. So this takes your 4160 from the Q20 breaker, knocks it down to 480 volt three phase for all of our 480 volt auxiliaries. So the low voltage side, the 480, comes out of this transformer and goes into our ADP, which is right here. This is the ADP. So all of these feeds, and you can see they're labeled as well, but they're labeled as far as what they feed. This one feeds the USB, RCP, vent fan 1 and 2, spare UCP supply. So from the transformer low voltage side into the ADP and then out to our various auxiliaries. And then right here, you see that's already open. This is our generator disconnect. Also low voltage. Comes from the choke, the tap of the choke, through the GDP, into the generator, all medium voltage. Again, it's a disconnect with a fuse as well, so it's a fuse disconnect. And here you can see the grounding blades that effectively ground it from the generator side when the disconnect is open. So those will be taken out. Okay. All right, so again, coming out of the GDP, go from the choke tap to the GDP, and then out into our generator junction box. So our alternator is the middle piece. Medium voltage 4160 alternator can function as a motor or a generator. On the left side, we've got our flywheel, our kinetic energy module. Starting near the alternator, we've got the exciter for the DC injection. This is the exciter that feeds current into the DC windings of the outer rotor, which grab onto the inner rotor. And then on the other end, we've got our pony motor, our three-phase asynchronous motor that actually will spin the flywheel. And you can actually see the, if this were to be spinning, you can actually see the inner rotor and the outer rotor, and you can see them spinning in relation to one another when the unit's running. Right now, of course, everything is at a standstill because it's off. The inner rotor has a set of proximity sensors, such that if for whatever reason the bearings start to falter and the inner rotor starts to shift, the proximity sensors will sense that and they'll send an alarm to the unit. So we're actually sensing the position of the shaft to make sure that the inner rotor is nice and stable. We also have measurements of temperature and vibration on the bearings. So we have 3 distinct ways of telling us when we have possible bearing issues. As well as a pickup for speed sensing is in here as well. Below here, below the pony motor, we have the actual control panel for the PGM. We call this the PCB, or Power Module Control Box. It just contains some PLC interfaces. So if you look, it's got some power supplies. It's got some chargers here for the diesel start batteries are located in here. It's got this little device right here. This axial line device is basically our interface with our PLC and the UCP. So through this device, our PLC can communicate with this panel and be used to control things like diesel speed, AVR of the generator, and so forth. All of our sensors from our temperatures, vibrations come into here as well. This little device, this IntelliNova device, is basically measuring the vibrations of the unit. So again, all the interfaces we need from the UCP to the PGM come through this box. All sensing points from the PGM to the UCP go through this box, and all the network connections and so forth. We have 2 additional e-stop buttons, one on each side, on each side of the pony motor. So these buttons will function the same as the UCP e-stop function. They all operate the same way, just push them if you need to. On the top of the alternator itself, you'll see the generator junction box. And there's a little window there on the left side. That window is actually looking at the AVR. So there are some light indications on the AVR that will show some alarms. You can see those through the viewing window. But the AVR is located inside that box, where it basically states it is a digital AVR. It has its own protections against overexcitation, much more advanced than the old style analog AVRs that we've used in prior generations. Okay. Continuing to walk around, just want to bring attention first to the USP panel, unit speed up panel. Again, this is being fed from the ADP, critical 3-phase 480 volts. Inside this panel, you'll find the frequency drive for the pony motor. It's a Yaskawa drive, so it controls the pony motor itself. And then on the bottom right-hand corner, you'll see our rectifier, which sends DC current to the field winding of our DC excitation machine for actual extraction of energy. So this is the device that the PLC controls to extract the energy or to send DC to the outer windings of the outer rotor for extraction of energy from the flywheel. Of course, it has its own PLC interface card, so it can communicate directly with the PLC as well. Diesel start batteries for when we have to first start the unit or black start the unit. We're going to put a plastic protective covering around it. Right now it's exposed, and that's a little dangerous, so we're going to put a little plexiglass cover on it. On the right side, between the alternator and the diesel, you'll see our freewheel clutch, with a side indication for the actual oil level. The oil that we use in here is actually just like a motor oil, like 10W40, I think. So it's a very, very standard motor oil. We do change that out once a year, is our expected change out for the oil. You can't see it on this side, but on the other side, there's also a temperature sensor and vibration sensing for the clutch as well. Then, of course, you've got the engine itself, Black Cummins QSK60. It's got crankcase ventilation recovery system, and it's a Cummins engine, what can I say? It's got dual exhaust out, comes into a Y system that goes up into the muffler. It's got the 4 turbos on top. It's a 16-cylinder engine. Right now we're standing near the fuel pump there. So this is the fuel return from the engine. This is one of our isolation valves. This goes back to the day tank. So again, one of those valves that needs to stay open. On the other end there, you've got the supply valve coming into the fuel filter. Another valve that needs to stay open.
Are there pyrometers on the cylinders?
Sorry?
Pyrometers on the cylinders measure cylinder temperature. Is there any way for us to measure that?
There's no way for us to monitor that without calling Cummins in to connect to the engine and monitor through their system. But yeah, the only information we extract from the diesel is the water temp, lube oil pressure, engine running hours, and we monitor some alarms as well, some discrete alarms like from the engine, high temp, low pressure, check engine light, and stop engine light.
RPM?
RPMs we do with our own pickup, yeah. But anything else in addition to that, fuel pressures and stuff like that, we have to get Cummins to come in and connect, and they can read it through their system. Okay. Right here on the other side of the engine, this is our redundant start panel. It looks like McKinstry has already started putting some extra labeling on there, which is nice. Tells you what the acronym means at least. But this is the rectifier, again, fed by the ADP, rectifies it into 24 volt DC, sends right to the start motors, which are on the other side of the engine, to crank the flywheel and start the engine. Right, come around to the back of the engine, you'll see the water connections. You've got the incoming for the high temp circuit right here, coming into this big pipe here. And then you've got the incoming from the low temp circuit, comes in here. And then you've got on the top of the engine, you got your high temp circuits coming out in two places, going into a Y and returning to the radiator. And then your return for the low temp circuit is a single connection in the middle of the two of those. So you got four big main pipes going all the way up the roof for the radiator. I don't think we'll take a trip to see the radiator, but it's a, you know, on your own time you can go take a look at it. It's a standard, you know, typical radiator. Notice all the isolation valves that obviously have to be open unless you're doing some kind of service to the cooling circuits. You've also got some vent line connections also from the engine that go up to the airspace of the expansion tank of the radiator. Also here on the front of the engine, you've got our preheat. This preheat is sourced from the utility side of the switchgear, from the ATP and the switchgear, the little 45 kVA transformer. Comes through the UCP and into this box here so that we can preheat the engine. Right now it's cold again because everything is shut down, but normally this would be keep the engine warm so your block is nice and warm. And then also on this side we've got the Prelube Pump. So this is the Prelube Pump. It as well is sourced from the 45 kVA transformer in the switchgear through the UCP. So ever so often, maybe once an hour or so, it'll run for a couple of minutes just to maintain lubrication pressure and keep the oil lubricated. It's very noisy, so that's the noise that you'll definitely hear when this thing is running. And then you've got your start motors. You've got 2 start motors for the engine connected to your batteries and your RSP for turning the flywheel upon starting. Clutch again. Clutch has another side glass. Has side glass on both sides. Okay, this is our what we call our day tank. Of course, it is raised for that, you know, gravity feed. Notice pipes coming in and out of the tank. One supplied to the engine and returned back from the engine into the fuel cooler, back into the tank. With isolation valves, again, make sure the valves are open in regular operation. We have our fuel control panel here. Light indications for letting you know various alarms or status of call for fuel, for example. The meter, the gauge that I mentioned to you that is not operable is right on the front of the panel. We're going to put a power supply in here so that we can actually use that gauge, but there is a gauge on top of the day tank. You just have to get up on a ladder to look at it. Got drains for the main tank and for the secondary tank. Obviously, being a UL-142, if there happens to be a leak in the tank itself, it ruptures, it'll all be contained within the secondary tank. And then you've also got on top, it's kind of hard to see, but you do see the return pump. That return pump will come on when we get a critical high level. And then it's also hard to see, but there are 2 sets of supply valves that will open whenever we call for fuel. And we'll send a signal to pressurize the line and open those valves so that we can fill the main tank from your bulk tank. There's also 2 sets of emergency shut-off valves as well. So if we get a high level indication, then we'll shut those valves as well. And then you just got your piping to and from the bulk tank along with their isolation valves as well. Again, fuel cooler on bottom. Fuel cooler fan will come on when we get a diesel run command from our PLC into this fuel control panel. This is about, let's see, I think it's about 200, well, that's the rupture basin. I think the main tank itself is around 175 gallons, I think, of usable fuel. At full load, that amounts to maybe an hour of runtime or so at full load. So this is our DC panel. Again, it's fed from the ADP for one feed for one of its rectifiers, and then from our UCP for the other rectifier. So there's two rectifiers for charging the station batteries in this panel, and then you've got the batteries down below, basically providing your 125 volt DC control voltage for your batteries and the medium voltage switchgear. There's a 120 panel, or 125 volt DC panel on the side for your individual feeds for various controls into the switchgear. So not only do we feed control voltage for the breakers, but we also feed the heating elements in the switchgear itself, or the panel heaters in the switchgear. This is the actual panel that turns the radiator on and off. So we communicate with this panel as well through our PLC. We give it an engine run signal, and then it will basically close the contactor to send voltage to the radiator up top and run the radiator. It is a soft start. There is a soft start in here for the radiator motor, and with all the requisite protections for the motor itself, and feedback into our PLC for alarms and so forth. One thing that we found out about this particular panel in soft start is whenever we energize the panel during a first start of the unit, it does an initialization of some sort with the soft start, and it actually runs through an alarm sequence, and when it receives voltage, but it starts to initialize with the voltage that is too low, but then ultimately comes to 480, it will actually trigger a fault. So on a first start, you might see a fault condition pop up here and at the UCP. We have to clear that with the reset and at the UCP, and then it'll be fine. We've actually adjusted there's kind of a delay that we can adjust to automatically clear that fault, and I think we set it for 15 seconds or something. But you might still see it at the UCP, but that's only for a first start initialization. After that, you won't see it. I might have to change the program to kind of put a timer on that at the UCP as well. But this should clear itself. That alarm might still stay active, so you might have to clear it at the UCP. We'll probably see that tomorrow when we start it up. All right, system data panel. This is a separate SCADA monitoring panel. It's separate from the other controls, and basically it has nothing to do with the operation of the system other than its monitoring. But it allows the customer to come in and extract information to their BMS through this panel. But also, you can also use the SCADA function if you want. And running our SCADA client on a laptop, you can actually monitor the system through SCADA as well, and some control as well. So basically in this panel you have what we call our box PC. All that's doing is basically recording and storing information that it gets from the system. So it's recording logs and storing logs, snapshots of plots, storing history, so that at any time, if you need to come in as a maintenance, for a maintenance evolution and take a look at the log history for troubleshooting, or for whatever reason, we can go and extract information from this to see what is going on with the system.
Where's the port that you plug into?
The port you plug into is this one right here. So you notice this cable says customer Modbus. So that's the customer port that they will plug into, so that you'll be able to extract information from our system. But strictly for monitoring only, this panel obviously communicates with our PLC as well, and you'll see a demonstration of this tomorrow, as well as some slide presentations of it as well.